just one addition. It's just because of this effect that you have of temperature on the density structure that actually supports the creation of heat waves, of marine heat waves in the ocean, or the creation of regions which have very warm surface temperatures. Okay, this is facilitated through the surface mix layer, and the thickness of this layer plays a big role because the heat flux that you have at the surface is distributed over the thickness of the mix layer. And this, I want to make that a little bit more clear with the next slide, which actually shows you how a surface heat flux results in heating or cooling of the surface mix layer. Okay, so there's a little equation shown here to illustrate that, because equations are the most the easiest way to illustrate what happens. Let's have a look at that formula. So what it tells you is it's an equation, okay? And on the left side of this equation, it shows dt dt. Capital T is temperature and lowercase t is time. It's what we call the rate of change of temperature. Okay? So how much does the temperature change over an hour or over a day? So this is the question that we ask, and the answer is given on the right-hand side of this equation. It's on the right-hand side, and there are a number of parameters on that side. Okay, the top one is the heat flux. Okay, this one is the residual heat flux at the sea surface. If it's positive, means temperature will increase. If it's negative, means the temperature will decrease. Okay? The larger the number means the faster will this change. There are other factors in here. The density. Density doesn't change very much, so it's almost like a constant, seawater density. Cp is the specific heat capacity. Also varies a little bit or so, but it's essentially also a constant. And the big factor of influence is this H here, and this H is the mix layer thickness. And it is divided by the mix layer thickness. So if you, for example, double the mix layer thickness, you actually halve the rate of change. Okay, so the mix layer thickness tells you it controls the rate of change together with the heat flux itself. Okay? So this is how the surface layer heats up or cools down. It becomes a little bit more complex because the heat flux itself has 4 different components. It comes from the solar radiation from the sun, so-called incoming shortwave radiation. The sea surface emits radiation, it's long-wave radiation. And then we have a sensible, which is a direct heat transfer between the atmosphere and the ocean. And we have a latent heat loss due to evaporation at the surface. It's a little bit more complex, but you learned a little bit of how does the heat flux at the sea surface relate to a warming or cooling of a layer of fluid. Okay, so let's have a look at the surface freshwater fluxes.